This recording is going to take you through the answers to the physics paper for the Pinehurst High School mock exam in September 2013. Alright, let's have a look at section A, the one-word items. 1.1 asks for the sum of an object's kinetic and potential energy, that we call mechanical energy. 1.2, the product of force times velocity. If you're going to have a look in your data books, you'll see that force times velocity is equal to power, and so the correct answer there is power. 1.3, the name of the unit equivalent to a joule per second. Now, joule is a measure of work or energy, and second obviously is time. So joule per second is referring to the quantity work divided by time. Again, having a look at your formulas, power is work over time, and so the name of the unit equivalent to joule per second would be the unit for power, so the correct answer there is the watt. 1.4, the total energy delivered by a cell to a coulomb of charge, that's called the electromotive force, or the EMF. And then finally 1.5, the substance separating two plates in a capacitor is known as a dielectric. Alright, that's question 1. And let's go on to the multiple choice then. 2.1 gives you a graph that represents the motion of a ball thrown vertically upwards from the top of a building. So you've got someone standing on top of the building and the ball gets thrown vertically upwards. Under the action of gravity, it'll slow down, stop, and then fall back to Earth. So let's have a look at the velocity time graph we're given. It starts at a positive 10 meters per second, so the ball's thrown up with a velocity of 10 meters per second. After 1 second, the velocity is 0. That means it's reached its highest point. And then right down towards the bottom of the graph there, you can see it has a downwards velocity, a negative velocity of 60 meters per second. So let's consider the options we're given. A is decreasing speed. Remember, speed is the scalar. And in this situation, the speed does decrease for the first second, but then it increases in the opposite direction. So A is not correct. B, a constant acceleration is correct, but of course the ball's accelerating downwards, not upwards. And so upwards is incorrect, so B can't be the correct answer. C, constant increasing speed. Again, they use the word speed there, and you can see that the speed decreases on the way up, so that can't be correct. Looks like D is the option. Let's have a look. Constant acceleration, that's correct. And that acceleration is downwards, both correct. So D is our correct answer. Right, 2.2, relative velocity question. We're told that the train is traveling east at 100 kilometers an hour and an aeroplane west at 300 kilometers an hour. Now, there are various ways to do this. Some people just have an intuitive understanding of how to do these. But if you do like to use the formula, we need to declare a direction to be positive. So let's take east as positive. We're asked for the velocity of the aeroplane relative to the goal. That's what the question asks for. So that is equal to the velocity of the aeroplane minus the velocity of the goal. The velocity of the aeroplane is 300 west, so that's minus 300. And we subtract the velocity of the goal, which is 100 east, so that's plus 100. And that gives us minus, oh dear, I've written meters per second. Sorry, that should be kilometers per hour. Minus 400 kilometers per hour. And that minus sign, according to our convention, is west. And so the correct answer there is A, given in the table below. All right, 2.3, flower pot is accidentally knocked off a balcony and falls freely towards the ground. Which pair of quantities will both change while the flower pot is in motion? All right, now, one of the quantities that most certainly will change will be its velocity. It's falling under the action of gravity, so it will accelerate, and so its velocity will increase. Let's have a look at each option. A, mechanical energy and mass. Well, mass certainly won't change as it falls, and so A can't be the correct answer. B, the kinetic energy is given by half mv squared, and there's our velocity, which will change, so that one will change. Momentum is given by the formula mv, and there's velocity again, so that will change. So B looks like it's a good option. Let's have a look at C and D quickly. C, gravitational acceleration. That's constant, so that won't change. So C can't be the correct answer. And then D, gravitational force. That again won't change, and so D can't be the correct answer. So 2.3, the correct answer is B. Right, 2.4. We've got three separate balls that are in contact with each other that are initially at rest. And then we have another ball of mass 2m coming in at a velocity of v, and it's colliding elastically. Now, there are two key concepts that you need to be sure of before we answer this question. The first is that momentum is always conserved in an isolated system. So the momentum before this collision must equal the momentum after. And remember that momentum is given by mass times velocity. So mvi, mass times initial velocity, must equal mass times final velocity. And then second, we told that the collision is elastic, and therefore we can conclude that the kinetic energy is conserved. So the kinetic energy before, half mv initial squared, must equal to the kinetic energy afterwards. All right. Let's have a look at the momentum before. We've got an object of mass 2m and velocity v. So the momentum before must be 2mv. And because of the law of the conservation of momentum, the momentum after must also be 2mv. So let's go through each option. A, the momentum is 2mv. We've got a mass of m and a velocity of 2v, so that gives us 2mv. So A is an option. B, our momentum is m times v, so that's not the same as the momentum before, so B can't be correct. C, the momentum after is 2m times 2v, which gives us 4mv, and that's not the same as the momentum before, so that can't be the right answer. And option D, our momentum after is also 2mv. So A and D are options when we consider momentum. If we now consider kinetic energy, the kinetic energy before the collision is given by 1/2 times by the mass, which is 2m times v squared. And if you multiply that out, the kinetic energy before is mv squared. So let's have a look at A. The kinetic energy after is 1/2 times by the mass, which is m, times by 2v, that's the velocity, all squared. If you multiply that out, it gives you 2mv squared. And our kinetic energy before was only mv squared, and so A can't be our correct answer. So it looks like D is the best option. Let's just check the kinetic energy here. It's 1/2. The mass is 2m, the velocity is v squared, and if we multiply that, we get mv squared, and that's equal to the kinetic energy before, and so D is our correct answer. Alright, 2.5, we've got a displacement of a particle on a straight track. Remember that the gradient of a displacement time graph gives us the velocity, and the options that we're given below are all velocity time graphs. So let's look at the gradient of this displacement time graph, and then we'll try and work out which is the correct velocity time graph. At the start, in the first couple of seconds, we have a very steep gradient, so our velocity is high, and you can see that that is a positive gradient. Later on, the gradient becomes slightly flatter, so the velocity is lower, but it's still positive. Up here, the gradient is 0, so the velocity is 0. A little while later, we've got now a negative gradient, and so we've got a negative velocity, and that would be a low value, and then the gradient gets steeper, so the velocity must be higher, still in a negative direction. So it starts off high positive, then becomes low positive, then hits 0, then goes for low negative, and then higher negative. So let's have a look at our options. C can't be the correct option because the graph starts at a negative velocity, and we've seen that we need to start with a high positive, so we can immediately discount C. If we have a look at B, you'll see that there are no negative velocities at all, and we've seen that there must be some negative velocities, so B can't be the correct answer. A starts off with a high positive, that then becomes a lower positive, that's correct. It goes through 0, which is correct. It then becomes negative, which is correct, but then suddenly it goes back up to 0, and we see that doesn't happen. So A can't be our correct answer. Let's look at D. it starts off as a positive, a high positive number. It gets lower, it goes through 0, which is correct, and then it increases in the negative direction. So D's our correct answer. All right, 3 statements regarding car safety. Whenever you're considering forces to do with car safety, we're thinking about impulse. And the impulse formula is F delta T equals M delta V. M delta V, of course, is your change in momentum. Now, for any car crash, that change in momentum is constant. So your impulse must be a constant amount. M is the mass of the car system, which doesn't change. Delta V is the change in velocity. And for any given accident, that remains constant. So let's have a look at our options. 1, airbags decrease the forces exerted on passengers during an accident. That's true because they increase the time for the collision as the passenger hits the airbag and they are slowly brought to rest. By increasing delta T, you're decreasing F. So 1's a good option. 2, crumple zones decrease impulse during an accident. Now that's not true because the impulse is set, it's the change in momentum. And then finally 3, seatbelts will stretch slightly. That is true. They are designed to stretch just a little bit during impact, and that increases delta T again and therefore decreases F. So 1 and 3 are correct, which means that D is the right answer. All right, 2.7, 2 resistors in parallel. Initially with the switch open, which just gives us 1 resistor, and then when we close the switch we get 2 resistors in parallel. And the question asks what happens on the ammeter, which is giving you the total current reading, and on the voltmeter, which is giving you the voltage over R1. Let's start by appreciating that once we close S2 and we have 2 resistors in parallel, the total resistance of the circuit decreases. The EMF is constant because we're told that there's negligible internal resistance, and so if the EMF is constant, then the voltmeter over R1 will remain unchanged. It will still read the total voltage, which will in this situation be the same as the EMF. So V will remain unchanged. Now what about the ammeter? That's measuring the total current. Total current I is V over R. And if R total is decreased, that's the first thing we said, and V remains constant, then our current must increase. So our total current will increase, the reading on the ammeter will increase. So that means A and B can't be correct because they both say that the reading on the ammeter will decrease. C, it has the correct answer for the ammeter, it will be greater. But the option C says that the voltmeter will decrease, and that's not true, so that's not the correct option, which leaves us with D, an increase in the current and a constant voltage reading. Right, electric field strength, a distance A and then a distance B, which is twice as far. So we're just changing the distance. The formula is for electric field near a point charge is E equals KQ over R squared. Once we go from A to B, the new electric field, use the same formula, K is the same, Q is the same, but the distance now between Q and B is 2R. It's twice as far as A was, so it would be the distance squared, so 2R squared, which will give us 1 over 4. We take that out, KQ over R squared. And of course KQ over R squared is just our old electric field strength, so that shows that the new electric field will be 1/4 of the old one, and that's option A. Alright, 2.9, electrical motor, and the question asks you which of these statements is incorrect. Let's start by identifying the positive and negative sides of the battery. So conventional current runs from the positive around to the negative. So if we then apply Ohm's law, the left-hand motor rule to the section AB, we'll see that the force is downwards on AB, so that's a correct statement. In the vertical position, you'll see that the split ring commutator, the gap in that aligns with the brushes, and so no current flows at that point, and so that's correct. C, the commutator reverses current every half turn, again that's correct. and D can't be correct because it contradicts A. So D's the answer they were looking for. And finally, 210, the correct answer is A. The other options, increasing voltage certainly doesn't increase safety. In fact, it decreases safety, so that's not true. Such a high voltage is not required in factories. They're using between 20 and 50,000 volts. In terms of the current, power is voltage times current, so if the voltage increases, the current must decrease, so D is also not correct. So 210, the correct answer is A.